Hello, this is Dr. Mears. Today we are going to be looking at graphs of constant and not constant rates of change. I have already done some work here, which I would like you to pause the video and fill in. We have worked on finding if it's constant or not, and that's the work that I put into this before I actually started graphing. So here the work that I did. I did 0 minus -6, which gave us 6, 3 minus 0, which is 3, so on and so forth. And on the other side, the x side, I did -1 minus -5, which is 4, 1 minus -1, which is 2, so on and so forth. I then turned each of these into ratios. Remember, the ratios, we're going to be dividing the change in y, which is going to be this column, by the change in x, which is going to be in this column. So I did 6 divided by 4, which is 6 divided by 4, 3 divided by 2, 3 divided by 2, and 3 divided by 2. Now this might not look constant because we have our 6 divided by 4 here, and this is 3 divided by 2. But if you reduce 6/4, it does reduce to 3/2. So they all are the same when you reduce, which means that it is constant. So let's see what the graph looks like since we know that the ratios are going to come out to be equal and it has a constant rate of change. Let's see what that looks like on the graph. So the first thing that we're going to do is we need to plot this point, -5, -6. So -5 on the x and then up or down to -6. So you always remember, you always have to do the x and then the y when plotting points. When graphing the line, it's going to be different. But when plotting points, we have to do the x first. So starting at 0, 0, I need to go -5. So -1, -2, -3, -4, and -5. And then what I'm going to do is I'm going to go down 6. So 1, 2, 3, 4, 5, and 6. So making sure 3 and then 1, 2, 3, 6. So here we go. Now I drew these little check lines in because this is, I'm just counting by ones, and so I just put this is 10 here and that's -10 here. So this is the point -5, -6. Let's plot -1, 0. -1, 0 is going to be right here. So you just go to -1 and the y value is 0, so you don't go up and down anywhere. This is +1, 3, so we go over to +1 and up to 3. And then we're going to go 3, 6. So 1, 2, 3. And then we're going to go up to 6. 1, 2, 3, 4, 5, 6. And then we're going to go 5, 9. So we're going to go over 1, 2, 3, 4, +5. And then we're going to go all the way up to 9. And if you notice for this graph, it is in a linear function. It is a linear function. It is a line. If we connected these points, it would be in a straight line. So when you have a constant rate of change, your graph is going to become linear. So all of these points follow a straight line. If one of these points was not in this line, then either A, you graphed it incorrectly, or B, you have to make sure that to make sure that it's constant. You didn't mess up your math. So this is how you check using graphing. If it's linear, it's constant. Let's see what happens if it's not. So the second example down on your page, again, I did some work. I checked to see if it was constant or not. So I found the change in y and the change in x, and I divided it. And none of these fractions would be able to be reduced to be equal. So all of these would have to be equal, and none are, which means it's not constant. So let's see what that looks like for this table. We know it's not constant. Let's see what the points look like. So I'm going to plot my points. I'm going to go -8, which is here, and then up to +9. -7, which is here, and then I'm going to go up to 6. 1, 2, 3, 4, 5, 6. -1, and then up to +5. 1, 2, 3. +1, and then I'm going to go up to 8. And then +6. And then I'm going to go down to 4. If you're having trouble graphing points, please, please, please come and get extra help. We're going to be graphing a lot of points in this unit. So this video was not only good to show you what constant and non-constant rates of change are, but plotting points. So let's go back to our not constant graph. If you look, do the points fall in a straight line? No, they don't. They don't fall in a line at all. We have this one hanging out down there. And they're basically scattered amongst themselves. So this is what a not constant graph looks like. And if we have a constant rate of change, this is what a constant rate of change. They all fall in that nice linear pattern. This has been graphs of constant and not constant rates of change. I hope it helps. Continue on with your work. Thank you.